Hi everyone. Today we are going to study convolution theorem, a topic in Laplace transform. So we will use this convolution theorem whenever we have product of functions f of t. Let me take the function as f of t and g of t. Whenever you have two functions, okay, we will be using the concept of convolution theorem. So let's study the standard definition of convolution theorem. As I told you, convolution is nothing but taking the product of given two function and obtaining the result in terms of another form. Transforming the product of one function to transformation of another function. Okay. So that is convolution of f of t and g of t is denoted by f of t into g of t. That means product of two function. And how it is defined? F of t into g of t will be equal to integral 0 to t f of t minus u g of u into d. For understanding the problems, you have to learn few results pertaining to convolution theorem. The first one is f of t and g of t. That means product of f of t and g of t can also be written as g of t into f of t. It will satisfy this formula. And if you take Laplace transform of product of function independently, that means Laplace of f of t into Laplace of g of t, you can write this together Laplace of f of t into g of t. Check out the third result. We have already stated this in Laplace transform. Laplace transform of f of t will give f of s. Okay. Now we have taken another function, Laplace transform of g of t, whose solution will be a function of s, that is g of s. If this is there, then just take the product of these two, f of s into g of s, f of s into g of s. Can I write it as Laplace of f of t into Laplace of g of t? As we know from the second result, Laplace of f of t into Laplace of g of t can also be written from this second result. Okay, from result 2, I can rewrite this as Laplace of f of t star g of t. So, whenever you have the function, two functions are defined in terms of s. That means the question is given in terms of two function of s. Then you can simply find the Laplace of f of t star g of t. This is your third result. Going to the fourth result, you can see the results of third. From here, if I want to find what is f of t and g of t, you can simply transfer this Laplace on the other side. So it becomes inverse Laplace, right? So from here you can obtain f of t, that is L inverse of f of s star g of s, that is product, okay, will be equal to f of t into g of t. If you want f of t, g of t, find L inverse of f of s into g of s. If you have f of s into g of s, then find Laplace of f of t into g of t. So our fifth result is, okay, f of t into g of t, we know its convolution formula, right? So from this, how to get L inverse of f of s into g of s? See the result. L inverse of f of s into g of s can be written as f of t into g of t. Go back to the formula, f of t into g of t can be written as integral 0 to t f of t minus u g of u into du. So I can rewrite the formula, L inverse of f of s into g of s can also be written as f of t into g of t. But what is f of t into g of t? Integral 0 to t, from the standard definition, 0 to t f of t minus u into g of u du. You can also write this as 0 to t g of t minus u into f of u du, because already we have stated f of t into g of t can be written as product of g of t into f of t. These results are very important for problems of convolution related to two functions.